Welcome back, mathematicians. In this video, we are going to learn about properties of functions, specifically even and odd functions given a graph. So let's look at the graph of an even function. The graph of the function is symmetric with respect to the y-axis. So what this means is that for every ordered pair x comma y on the graph, there also exists a corresponding point of the opposite of x value, comma, and the same y value. Let's look at the graph of odd functions. The graph of the function is symmetric with respect to the origin. And what this means is that for every ordered pair x comma y on the graph, there is also a corresponding point of the opposite of x value and also the opposite of y value. So in other words, if you have 2 comma 3 on your graph, then you would also have negative 2 comma negative 3 on your graph. So let's look at each of these examples and determine whether it's an even function based on the symmetry with respect to the y-axis, an odd function based on the symmetry with respect to the origin, or neither. And so looking at the first one, I'm going to go ahead and pick a point on the graph, which I pick 5 comma 5. And does there exist an ordered pair that satisfies my definition, which says that it should have the opposite x value but the same y value? And the fact is that that is true. We do have a point on the graph, which is negative 5 comma positive 5. And does this hold true for all points on the graph? And the answer is yes. So therefore, this is an even function. And you can see that there is symmetry with respect to the y-axis. This one's probably the easiest one to visually determine based on the mirror image on the right and left side of the y-axis. Let's go to the second example where we are given a graph, and again, let's find a point that we can clearly identify on this graph, which I can see that I have 2 comma 8. So 2 comma 8 is a point on the graph. And does there exist a point that is across the y-axis, which would be negative 2 comma positive 8? And the answer is no. So it is not symmetric with respect to the y-axis, which means it's not even. Let's see if we can find a point that is at negative 2 comma negative 8. And we do have a point on our graph that matches that description. So negative 2 comma negative 8. Does this hold true for all points on our graph? And the answer is yes. So as a result, this is an odd function. Let's go to the last one, and while we do see that this parabola is actually symmetric, it is not symmetric with respect to the y-axis, and it is not symmetric with respect to the origin. To check our hypothesis, let's pick a point on the graph, which I can have a point here, which is at 3 comma 2. Do we have a point across the y-axis, which would be at negative 3 comma positive 2? And the answer is no. So that point would be right here, and that point is not on the graph. So no, it is not symmetric with respect to the y-axis, which means it's not even. Do we have a point that is at negative 3 comma negative 2? Well, no, we do not have that point on our graph either, so it is not odd. Now, as I just mentioned, it is symmetric, but it is not symmetric with respect to the y-axis or the origin. It's symmetric with respect to this line, which again is not the y-axis and not the origin, which means that it is neither. So while your graphs can have symmetry, if they are not symmetric with respect to the y-axis and they are not symmetric with respect to the origin, then the answer is neither. And it's not an even function, it is not an odd function. All right, guys, good luck.